So now we will discuss about supervised machine learning again in more detail actually. So as I told you that in supervised learning, you provide your machine with the labeled data, right? Everything is clear. The labels are already available that this is the price, this is the area of the houses, right? It means the machines, they are trained with well labeled training data. Okay, well labeled training data, and on basis of that data machine predict the output. Okay, so by labeled data, what I mean that some input data is already tagged with the correct output. It means when you feed the data, first of all there are labels. This is the area of the house, this is the price of the house, and if I'm giving the area 2200 square foot, whatever the area is measured in, and the price is 5,000, then this particular pair of value that I am feeding to your machine, it is accurate, 100% accurate, that if there is a house of this area, then its value is this. It is correct. The output is correct with respect to the input. First property is that the input and output, they are properly labeled. The machine knows that 2200 value is of area variable and 5,65,000 value is of the price. Second thing is the output is always correct. It means if there is a house of 2200 area, the price is always 5,65,000. Okay, so the training data provided to the machines in case of supervised learning, it works as the supervisor that teaches the machine to predict the correct output. Okay, and I told you that it is same as that of the student teacher concept, in which the teacher is the supervisor of the student. Okay, so now let's study it in more detail. That supervised learning is a process of providing input data as well as the correct output data to the machine learning model. You are providing input data, input and output both are labeled. You are providing input data and correct output data. So it means your machine is now learning that for this input, the actual correct output is this. Okay, when the data is 100% factual, it is fact. So it means whatever your machine is learning, it has strong foundation, so that in future if it is predicting, so that foundation will help your machine to predict accurately. Okay, so the aim of supervised learning algorithm is actually to find a mapping function to map the input variable with the output variable. So for example, I gave you the example that this is your area and this is your price. Okay, so suppose area is referred as X, your price is referred as Y. Okay, so when you feed the data, so if you are feeding 2200 data, which is your area, you know the price, that is Y, will be 5,65,000. Okay, and then there is one more data, then there is one more data, and then there is one more data. So this data you feed to your machine. Now when you, after training, when you test your data, you give it the data 3,300, that is your X. Now you want that what will be the Y. It means you need to create a formula that how you can calculate Y using X. Okay, so there will be certain formula that is working behind it. If I say Y equals to X square, it means this is so suppose this is an example, I'm taking random equation. So Y is equals to X square, it means I am mapping my X with Y. This is my dependent variable, my Y is depending on X. So if X is 3,300, I know that my Y I can calculate from it by doing the square of it. So you need to find a mapping function, so that if you have X available, how you can calculate the Y. Right? In the linear regression, I told you that you can calculate Y equals to mx plus c. You remember this thing where this is the intercept and this is the slope. So you, the machine and we should always train that particular equation, so that whenever something new comes, on the basis of that equation, it can predict it. Okay. If I know m, if I know c, and I already know x, that is 3,300. I can calculate my Y. So this is the idea behind it. Okay, so when I feed the data, keep on feeding the data, right? It comes with this equation that the input, if this input, then this is the output. So the equation somewhat looks like this. So it automatically creates that equation, and whenever new data comes, it feed that data into that equation and gives you the output. Okay, so in real world, you use supervised learning for risk assessment. So whenever in the stock market you are applying you're just investing your money. Okay, so you always get a prediction in advance that there will be a risk, there will be a hike that will be coming in the days in future, and or maybe there will be loss side. So that prediction is on the basis of the previous data that they are continuously collecting. Image classification is also one example. Fraud detection is also one example. Spam filtering is also one example. These all are under supervised machine learning. Okay, so how supervised learning works? Okay, so can you see here, students? This diagram actually clearly explains it. Okay, so suppose when I say that I am feeding data, right? So just don't think about if the data is numerical, it is categorical, or it is ordinal data. Just think that this is the data. Sorry, this is the data. Okay, can you see it has mentioned that this data is labeled? By labeled data that you provide in supervised learning, what it means? It means that whatever data you are providing, it has a label. So if this is the data that I'm providing, this is one example, this one. Let me just so if this is the data, this is one data that I'm feeding. So what will be the label of this data? The label is that maybe in the form of the name. So how many sides it has? 1, 2, 3, 4, 5, 6. So you can say that it has a label that it is a hexagon. So you are feeding hexagon to your model. You are feeding square to your model. It has proper labels, maybe the names, maybe the number of sides. Okay, and then there is this, that the triangle you are feeding. Okay, so means some of the data that you are feeding, they are of the type hexagon, some of the type square, and some of the type triangle. It means the data is well labeled, and you provide this data to your model. Okay, so can you see the labels that I am telling you? It is already mentioned here that there are 3 labels of this data. One is hexagon, other data labels are triangle, and the third data labels are square. It means you are giving it an idea that, okay, these 3 types of data I am feeding to it. The first one is of the type hexagon, the second is of the type of square, and third is of the type of triangle. Okay, so your machine is now getting trained, right? It knows that now hexagon is there, this is hexagon. Whenever it gets a shape and it is getting this shape, your machine knows nothing about it. But when you apply a label to it, your machine knows that this shape has a label hexagon. So if similar shape like this will come, I will consider it as hexagon. The second label you are sending is you're sending a shape. Your machine knows nothing about it. But whenever you are attaching a label to it, now it knows that these kind of shapes should be recognized as triangle. Third shape that you are feeding to it is somewhat like this. Now your machine is again confused. But when you send a label along with this shape, square, so it knows that, okay, this kind of shapes are known as square. Now your machine is trained with these 3 kind of shapes, right? After training it, now you are going to test it. Test means predict. So what you do, you give it test data. So by test data means unlabeled data here, just the shapes you are giving to it. Okay, and what you are doing, you are sending it a square. Okay, so from the past data it has gathered, it has come across, okay, it has 4 sides and all the sides are of equal length, right? So it will predict that it is a square. The second data that you are feeding, on the basis of what you get already, it will predict that it is a triangle. So this is how your machine learning generally works. So let's go over it really quickly. So suppose we have a data set of different types of shapes, which includes square, rectangle, triangle, and polygon. So many shapes, right? Now, the first step is that we need to train the model for each shape. Okay. So if the given shape has 4 sides and all the 4 sides are equal, it will be labeled as a square. If the given shape has 3 sides, and it will be labeled as a triangle. These basic facts we know already. If the given shape has 6 equal sides, then we can say it's a hexagon, right? Now, after training, we test our model using the test data, and the task of the model is to identify the shape. Now, the machine is already trained on all the types of shapes, and when it finds a new shape, it classifies the shape on the basis of number of sides and predicts the output. Okay. Now, if you just say what are the different types of supervised machine learning algorithms, so these are of 2 types: regression and classification. Okay, so after finishing supervised learning theory, we will just switch to the techniques, their way of performing, and I will help you implement these techniques on data sets, right, side by side in the lab. Okay, so in regression particularly, there is linear regression, there is regression trees, there is non-linear regression, there is Bayesian linear regression, there is polynomial regression. So these are regression techniques. Okay, so linear regression is the one on which we are going to work next. Even in your theory subject, the next topic after supervised, unsupervised, and reinforcement learning is regression, linear regression. So what is regression? These are the algorithms, right, in which there is always a relationship between the input variable and the output. As I told you, x and y. So your output variable is always dependent upon the input variable. And it is used for the prediction of continuous variables that are continuously changing. If your x is changing, y is changing, such as, and moreover, those problems in which there is always change happening, like weather forecasting. Every day, humidity is increasing, temperature is decreasing, right? So these machine learning algorithms which focus on regression work on that data which is changing continuously, weather forecasting, market trends which are changing. Okay, so these are the algorithms that we are not going to learn today, but when we will do the technique, we will do the detailed study of all these. Then there is this classification. Classification also comes under supervised learning. Okay, where you just use when the output variable is categorized, right? Categorical, which means there are 2 classes: yes, no, male, female, true, false, on, off, kind of. And the examples are random forest, decision trees, logistic regression, and sport vector machines. So some of these techniques we will study in detail. So next comes the advantages of your supervised learning. So first of all, so the best advantage is that as you are feeding it with the exact output, your machine is learning and it gets the ability to predict the output on the basis of the experiences. Prior experiences means prior data, right? And here we can have an exact idea. I'm 100% sure that if I am being labeled in the training phase that this is a square, so next time if I'm getting a data like this, I am 100% sure to give it a label square, right? Supervised learning model helps us to solve real world problems like this and this. So it means here the accuracy of the output gets very, very close to the actual output. Okay, what are the disadvantages? It is not suitable for handling the complex task. I told you that in real world, we are always not sure that for this input, what will be the output, right? For problems where inputs are given and outputs we are not aware of, this supervised learning will not work, because for supervised learning training, you always want to feed input and output together to your machines. Okay, so supervised learning cannot predict the correct output if the test data is different from the training data set. This is the second problem. So suppose I'm giving you an example that when I trained my machine, I told it that this is a square, this is a triangle, and this is one hexagon, right? Sorry about my hexagon. But later on, so in the training phase, I gave the label data. But while testing, if I gave it a data like this, now my machine know nothing about it. So my machine, my testing data is different from the training data. So my machine will not be able to predict the correct output. Maybe on the basis of this, it will predict that it is one hexagon. So it will predict only out of these training sets. Okay. So training also required lots of computation time. When you are spending the time to train your machine, it means you are dedicating so much effort and time. So obviously it's a time taking task, and who wants to spend more time? So this is one drawback if you consider that training your machine is actually time consuming. So in supervised learning, we need enough knowledge about the classes of objects. So before training my machine, I should be aware of all the labels that I want to put. Okay, if I am training my machine and I don't know that what this is, and instead of feeding square, I am feeding it as circle. So it means I'm not able to provide the correct knowledge. I don't know about the class of object. The class of object is what is the class of this object? The class is square, but I am feeding the wrong knowledge. So we should be well versed. We should be well aware about everything about about the data. Okay. So next topic is unsupervised learning. So we finished supervised learning. So you know that unsupervised learning is actually the opposite of supervised learning. Okay, so just go to the slide. Says it as the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training data set. There's no training data set that is labeled. Instead, models itself find the hidden patterns. Okay, so the model is self-sufficient. The model that the algorithm that is working, it automatically tries to find the hidden patterns in the data. Okay, from the given data. It means it's not that data is not available. Data is available, but it is not labeled one. So the machine learning algorithm just go over the data and try to find the patterns and give it labels on its own. So it can be compared to learning, which takes place in the human brain while learning new things. Whenever we are learning new things, so if your teacher is telling you, so you are well aware, okay, this is the idea. This is the idea. So this is the logic. This is the logic. But when you are learning on your own without a teacher, so you are always confused. You think that maybe this formula is working or maybe that formula is working. So after applying the formula on one example, you will become sure, okay, yes. So you are using your own brain without the help of the teacher. So it can be defined as unsupervised learning. It is a type of machine learning in which the models are trained using unlabeled data set. So if someone will ask you what is the difference, so you will always say that in case of supervised learning, the models are trained with the labeled data set. On the other side, in case of unsupervised learning, the models are trained with the unlabeled data set. And the machines are allowed to act on that data without any supervision. No labels, no supervision available. Okay, so here is this example. So suppose the data set that you feed to your machine in case of unsupervised learning consists of image. This image is the data. Okay, and by meaning that unsupervised learning is happening, I mean that no labels are assigned. If you look at this image, we as a human, our brain is that intelligent, we will be able to assign labels to it very quickly. I will be able to assign labels to it by looking how my brain is working to apply labels, by looking at the shape of the creatures, right? So I will say that by looking at the shape, by looking at the height, by looking at the shape of the ears, and by looking at the color of the eyes, I will say that this is a cat. This is one label. According to me, this is a cat. The other label, no one is providing me any supervision, right? By looking at it. Okay, and this is a dog. This is a dog. This is a dog. Okay, so the same thing, same time. So suppose there is a newborn child and he is learning and he don't know about the creatures. Okay, so at that time, if you introduce new things to that child, that this is a dog, how you introduce? So by looking at that particular creature, by looking at the height, the way that creature walks, the length of the legs, the shape of the mouth, the length of the tail. So by looking at it on the daily basis, the child grab that, okay, this is a dog. Okay. Similarly, if you say that this is a cat, that child doesn't know anything about cat. But when you say, yes, this is a cat, so by looking at its height, the way it moves, the way it speaks, right? So that child will get an idea. Okay, so these kind of creatures are named as cat. Similarly with the colors, when a child is new to learning, that child doesn't know that this is red color. So you just introduce, this is red color. Again, you show a new thing in which red color is present. So this is again red color. So when he come across such colors again and again in life, right? So from those experiences, that red color adds to the knowledge of the child. Okay, this is red color. Got it? Similarly, your machine is struggling in the beginning. Okay, so example is given. So suppose the unsupervised learning algorithm is given an input data set containing images of different types of cats and dogs. The algorithm is never trained upon the given data set. That algorithm know nothing about it, that whether it is cat or whether it is dog or whether it is buffalo or whether it is horse, which means it does not have any idea about the features. No labeling is there. Okay, now the task of the unsupervised learning algorithm is to identify the image features on their own. So it will try to identify the features. So I'm not sure that it will be able to say that this is cat, this is dog. So it will identify the features on the basis of the shape, right? The shape of the ears, the color of the eye, the height of the creature, right? The shape of the mouth, and so on. Okay, so on their own, unsupervised learning algorithm will perform this task by clustering the image data set into the groups according to similarities between images. Now what that that algorithm will do, so it will analyze the structure. Okay, so the similar structures that it find, it will put that in one group. So these two will go in this group, and these three will go in one group. So it has just arranged it in two groups because the algorithm know nothing about that, whether this group is termed as cat or dog. It is just looking at the features and it is putting it into two separate groups.